So, the idea with this, when we have an equation with variables on both sides, for example, 6x equals 4x plus 18. The idea here, what we need to do, get all the variables, step one, get all the variables together on one side. Oops, there we go. Get all the variables together on one side using inverse operations. Remember, that means doing the opposite. It's just a math way to say undo by using the opposite operation. Inverse means opposite. So anytime we're moving things from one side to the other, we're always doing the opposite operation. So in this case, I've got two sets of variables. I'm going to suggest you always move the smaller amount. That will help you avoid some negative numbers. So in this case, 4x is less than 6x, so I'm going to choose to move the 4x. If I ignore the plus 18 and I just look at the 4x, I can see that it's positive, right? This plus here goes with the 18. So with the 4x, it's positive. So I'm going to do the opposite, which is negative or minus 4x. Again, on both sides of the equal sign always. Look where the equal sign is. Make sure you do it on both sides. 4x minus 4x, nothing left there except the 18 that was there when we started. Now on the left side, I can combine like terms. 6x minus 4x makes 2x. And now we can solve, finishing up, divide by 2 on both sides to get the x by itself. And we get x equals 9. So that's one way to get the variables together, or one example of doing that. I'll show you a couple others. Any questions on that one? By the way, you can go the opposite way. You don't need to write this down. You can just watch. I'm going to show you really quickly. If you had decided to move the 6x instead, we could do that. We could say minus 6x on both sides. If I do that, what's left here on this left side of the equal sign? What's left over, Carissa? 0. 0 is a number. 4 minus 6 makes negative 2x, right? This is actually going to make it a little bit longer. So you don't have to write this down. You can just watch. I'm just going to prove to you that it does make the same answer. I'm going to leave the variable alone. I'm going to undo the 18. I would do minus 18. Now I have 0 minus 18, which is negative 18, equals negative 2x. Now I divide both sides by negative 2. Negative divided by negative makes a positive. But you can see that way ended up being a lot longer. Not a lot, a little longer. And there's just more chance for making mistakes because of the negatives. So you can technically, you can move either one of the variable terms. I'm going to suggest you always try to move the smaller amount because it will make it simpler when you're doing the math. Okay, so now let's move on to another one. Let's try 3y equals 15 minus 2y. Next step, I'm going to get the variables all together. Which one do you suggest I move? Rebecca. Okay, good. Not only is 2 smaller than 3, but we also have a positive and a negative, so we'll take the negative. Now this is minus, negative or minus 2y, the opposite, plus 2y. Remember to always look right in front to see what sign there is. Now negative 2y and positive 2y will cancel out, leaving just the 15. On the left side, 3y plus 2y, combining like terms, I get 5y. And nice and simple here, we end up divide by 5, and y equals 3. Okay, I think we're ready to make it a little harder. It's not really much different, except, of course, making a fraction. Putting a fraction in there makes everybody freak out a little. 4/5 x plus 3 equals x. Uh-oh, I got x's on both sides, and one of them has a fraction. So let's think about this. We're going to keep it as a fraction. I don't want you to just take your calculator and turn it into a decimal. Let's think about it as a fraction. Before I start moving it, I'm going to rewrite this x. How many is this over here on the right? Luke? 1. So we could say 1x, but still with the 4/5, we could also call it 1x like this. 1 5/5. Right? Everybody with me that 1 is equal to 5/5? So what I did, and I picked 5/5 because this has a denominator of 5. Because here's what I'm going to do on here. I'm going to subtract 4/5 x from both sides. Well, it's easy on the cancel out part. That just leaves 3. But now on the right side, if I have my 1x, where the 1 is written in the right fraction form, then I'm going to be able to do this pretty easily. Instead of, and the x came first, so I need it to still come first, but I'm going to use this form, 5/5 x. There's my 1x minus 4/5 x. Now all we have to do is remember that when we're combining like terms, we're just doing the math on the coefficients, the numbers in front. So what is 5/5 minus 4/5? Daniel? 1/5. And that's how many x's I have left. So the combining of the like terms, we needed to turn that 1x into a fraction to make it easier. 1 minus 4/5. Some of you could do that in your head and get 1/5. You're welcome to do that if you can do it in your head. CJ?
Can't 1/5 be called x?
I don't understand the question. We had 5/5 minus 4/5 x, which makes 1/5 x is left.
Oh, yeah, never mind.
Okay, I didn't understand your question, so if you think of another one, let me know. Now, we're almost done. This is 1/5 times x. We need to solve for x. I'm going to divide both sides by 1/5. And I'm running out of room here, so I'm going to rewrite it over to the side. On the left, I have 3 divided by 1/5. The 3 comes first. 1/5 divided by 1/5, those will cancel out, leaving just the x. But I still have to do 3 divided by 1/5, which becomes, again, I'm running out of room, so I'm scooching to the side. You can just keep going down your paper. That becomes 3 times the reciprocal of 5/1, and then we're going to get 15/1, or 15 equals x. So again, just because it's a fraction doesn't mean you can't do it. You might have to think a little more. I got a couple more to show you. 2 more. Those last. Everybody good on that one? Okay, if I ever pull these notes down too fast and you're not ready or you didn't finish, just ask me later. I'll give you my notes to copy from. Okay, 2 more examples. First one, 8 plus x over 9 equals x. So this is kind of like when we were doing the multiple transformations back in, I think it was lesson 3.3. Before I start moving x's, I need to first undo this over 9 or divided by 9, right? Since this is divided by 9, I'm going to do the opposite, which is times 9 on both sides. We have to simplify first if we can. Now I'm left with 8 plus x equals, well, x times 9, 9x. Now I can get the variables together. I've got a plain x, I've got a 9x. Which one do you want to move? Pammy. Good, little old 1x. So I do minus 1x on both sides. 8 equals, well, 9 minus 1 makes 8x. You might be able to tell by looking, but just in case, we're going to do the opposite of times 8. We're going to divide by 8. And yes, the answer is 1.
Can I ask if this is Rachel's?
Oh, yeah, we got some glasses here.
Rachel, is this yours?
Oh, she's wearing them.
Oh.
Unless you got an extra pair. Are those somebody else's glasses?
Is this anybody else's? No? Okay. The office brought it up. Brought it over. Thank you.
Okay, last example. Let's add in the distributive property. Yay! Last example, 7 times the quantity x minus 2, parentheses, minus 6, equals 2x plus 8 plus x. This is about as complicated as you'll see today. Like the last one where we first undid the divided by 9, on this one we're going to first see what we can simplify before we move stuff. If you can simplify anything before you start moving things around, you definitely want to simplify first. So 7 parentheses x minus 2 minus 6 equals 2x plus 8 plus x. Let's start on the left side. I'm going to first do the distributive property. 7 times x, 7x. 7 times 2 with a minus in front, minus 14. I still have minus 6 from the original problem. Now, on the right side, can I simplify anything on the right side? Vincent,
2x plus x.
how much do I get?
3x.
Good, 3x plus 8. Can I simplify anything more on the left side now that I've done the distributive property? Jaden?
14 minus 6.
Okay, now be careful. We've got 7x, it's a negative or a minus 14, so we're going to want to be careful here. Subtraction is the same as adding the opposite. So I do that. I have negative 14 plus negative 6 makes negative or minus 20. You can say plus negative 20 or just minus 20. Okay, so a few steps of simplifying there before we can start. Now there's nothing else I can simplify here. There's no like terms. So now I can start moving variables to be together. Which one do you want to move? 7x or 3x? Vincent. Okay, good. Again, always try to choose the smaller one if you want to make it easier. So next step, I will move this over by doing the opposite. Notice up here we weren't doing the opposite, we were just combining like terms. So now we undo and we do the opposite here. 7x minus 3x is 4x. I still have minus 20 equals, I still have 8. Now I'm back to like lesson 3.3, multiple transformations, multiple operations. I leave the 4x alone. I start by undoing minus 20 by doing the opposite, plus 20. I get 4x equals 28. And finally, I divide both sides by 4, and I get x equals 7. Okay.